All right, everybody, it's Mr. Chang again, back at you with the very last lesson in trigonometry. This one's called Applications of Trigonometry. Really all it is trying to handle some of the more tougher questions, word problems and such. We've got two goals here. So the first one is to use or create fully labeled diagrams when solving problems. And the second one is to decide the appropriate formula for the situation. You want to do the second goal after you do the first one, because you want to look at what you're working with, right? And I've got a handy dandy trigonometry help flow chart right here. We'll have a quick look at that. And the first thing you want to ask yourself is the triangle right angled, right? That means, do you see this little marker there? If it's there, if it's a right angle triangle, then you want to follow this process and go, well, does it involve any angles? And if it does, then you're going to use SOHCAHTOA. Those are the trig ratios, right? At SOHCAHTOA, if you sub in, you can actually figure out an angle, or you could figure out a side, however you work with it, right? And you guys seem to do pretty good with that stuff. Well, what about if it's not, right? Like no angles are involved. You got no angles. That's all right. That's even better. We're going to use a Pythagorean theorem right there. Okay, c squared is equal to a squared plus b squared. Make sure you square root so you can find what c is. That's the other side you're looking for, right? That's for the hypotenuse. Or b squared is equal to c squared minus a squared if you're trying to do one of the legs that are attached to the right angle of a right angle triangle. Then we have here, well, what if it isn't a right angle triangle? Well, then, do you have a side and an opposite angle? If you do, sine rule, boom. If you don't, cosine rule. Boom, that's it. All right, and that's what we're looking at, and we just need to come up with a diagram, sub in, and see what we got. So here's our first example. It says in triangle PQR, we've got PR is 17.6 meters and PQ is 15.1 meters and angle Q is 70 degrees, and we have to solve the triangle. Just to be very clear, when we talk about solve the triangle, I'm looking for the value of all the angles and all the sides, okay? So all angles, you have to state them, and all the sides. In a question like this, I'll give you 3 of the parts, and you have to tell me the other 3, okay? I've got 2 sides, I need 1 more side, and I've got 1 angle, I need 2 more angles. So let's go. We've got PQR, and PR is 17.6, Q is 15.1, PQ is 15.1, and angle Q is 70 degrees. So, just thinking about it, if PR is a longer side, I'm either going to use like this side here or this side here, but I also need to identify 70 degrees, and honestly, like I think this is pretty close to 70 degrees, or either one. So let's go P, let's call this Q, let's call this R. Yeah, I decided this is closer to 70. Let's label, right? We know angle Q is 70 degrees. All right, and we know that PR is 17.6. Okay, meters. And we also know that PQ is 15.1. That's not going to match up very right. I don't really like that. So let me come in here and do a quick adjustment here. I think I'm going to call this Q at 70 degrees, just to try to match up with the way the drawing should look. And you guys will see that PR is 17.6. That's the longer side. That looks reasonable now. And PQ is 15.1. It needs to be the shorter one. For some of you guys who are pretty obsessive about your details, you wouldn't stand for a longer side being labeled as shorter. All right, so here we are. Let's get to work. We could figure out angles, we could figure out sides. Do we have a right angle triangle? And the answer is no. So is it sine law or cosine law? And if you look at it, we've got a matching angle and a side, so we should probably be using the sine law to work out everything we need. Okay, so I'm going to take a moment and finish off the labeling of this triangle. If that's angle P, this is lowercase p. If this is angle R, this is lowercase r. And if this is angle Q, this is lowercase q. And I can break out the sine law here, and I can use the sine law to figure out r right now because I've got the 15.1 there. Let's get angle r. Okay. Angle r. I'm going to write sine r over r is equal to sine q over q. And I could write is equal to sine p over p, but honestly, that ratio, I don't have anything for it, so I'm just going to leave it like this and sub in and solve. I'm going to do that in a quick moment, just by pausing. Did you get this answer? It looks to be angle R is 53.7. Okay, just make sure you set up with the sine law. You're going to sub in, you're going to multiply the 15.1 to both sides so that you can really isolate that R. And I just figured out what 15.1 times sine 70 divided by 17.6 was as a decimal. And then you got to do sine inverse to both sides so you can get the R by itself. And I got 53.7, so I can write that in. 53.7 degrees. All right, so, here's the thing. If we've got Q and we've got R and you're looking at a triangle, then the angle sum of a triangle, any triangle, is 180 degrees. So let's try to figure out P right now. Oops. P. Angle P. Angle P is equal to 180 degrees, which is a total, subtract Q and R. Okay, and if you do that, you get 180 subtract the 70, subtract the 53.7, and bam, there you go. So we've got Q, we've got R, we've got P is 56.3 degrees. Okay, we've got all the angles, check. We've got two sides. We are missing just this one green guy right here, that lowercase p. So let's figure that out, side P. So side P, you can write side P. What's a good strategy to use here? You could use sine law, you could do cosine law, but you really want to try to use what I have here that's highlighted here. Try to use as much of your original numbers as possible because, my 53.7 and my 56.3, these are answers that I have, but they're only accurate to one decimal place because I did round. So using the original numbers as much as I can, I think I'm going to use the sine law. Okay, so let's do that. I'm going to say sine P over lowercase p is equal to sine Q over lowercase q. And if we sub and solve, how about this? Right? Just got to make sure you sub in. We are trying to find a lowercase p here, so you're going to have to cross multiply and then divide out the sine 70 so you can get the p isolated. And lo and behold, you got 15.6. All right, I'm just going to come back to that, and just for novelty's sake, I'm going to write that in as well. That is 15.6 meters. And you can see that I have all the sides and I have all the angles, and that's that. Okay, all right. So these are more like the knowledge-based questions because I give you the details. All you got to do is draw in the triangle, fill in all the details, and solve for any of the angles or sides that we're missing. Typically, sine law, cosine law will get you everywhere you need to go. And let's talk about some word problems. So I've got a couple here, or three of them I want to do with you guys. The first one here is example 2, right? You got two dogs. They run in different directions from the front door. The bulldog runs 18 degrees east of north at 7 kilometers per hour, and the whippet runs 21 degrees west of north at 25 kilometers per hour. How far apart are the dogs after half an hour? Okay, bulldogs, as you know, they lumber, they are slow, they're typically tired very fast. And they're not really made to go, but whippets are really fast dogs. They are pound for pound, probably the fastest dog out there. That's what Google says. or some people call them the poor man's greyhound, because they're not really as expensive or as fast as greyhounds or high maintenance as they are, but they're, a lot of people keep whippets as house pets too. Okay, so let's do our labeling and all that stuff. There's a lot of details here, and there's a little bit of trick when it comes to these sort of speed-based questions. So let's give me a moment and I'll sub in the details. If we understand that the common direction of north is this way, then what's happening here is the bulldog went 18 degrees east of north. And, if you know the way that looks, never eat shredded wheat, going clockwise, then the bulldog went this way 18 degrees. Right? And the whippet went the other way. You can see the whippet runs 21 degrees. Let me just highlight what I talked about with the bulldogs. 18 degrees for the bulldog, and the whippet runs 21 degrees, right, going this way, 21 degrees. So we got 18 degrees for the bulldog going in its direction, and we got 21 degrees for the whippet going in its own direction. All right, so what does that really mean? It actually means that on the inside, we have what is 21 plus 18 degrees for this little angle here, okay? And we can do that in our head. That is 39 degrees, okay? So what I'm going to do now is I'm just going to take this little piece of work out, and I'm going to write in that this is 39 degrees. Okay? And that's out. The next thing we're going to talk about is, okay, we've got an angle, 39 degrees. What else do we know about these two dogs? Well, I gave you the speeds. You see, oh, that was a whippet there, right? West of north. Their speeds are given here, 7 kilometers and 25 kilometers, and they go for half an hour. You see, if I was to write their speed as 7 kilometers per hour, here is 7 kilometers per hour, and this is 25 kilometers per hour. These are my side lengths as speeds, and if my side lengths are speed, well, guess what my third side length is going to be? A speed. But if you look at the details, I'm not looking for a speed. I'm looking for how far apart are the dogs. I'm looking for how far apart are the dogs here. And only if I change my speed to distance am I going to get distance here. Okay? So let's deal with that. This 7 kilometers per hour is what, right? So what you guys need to understand is we have a little bit of a side detail we got to work out. What it is speed is equal to distance over time. And if you want to figure out distance, well, distance is equal to speed times time. Okay, well, what's the time? The time we go for is half of an hour. Okay, half of an hour is 0.5 of an hour. So in the first case, talking about the bulldog, the distance here is d, right? And we are talking about bulldog, is equal to the speed, which is 7 kilometers per hour, times the time, which is 0.5 hours. He doesn't go a full hour. If he did, he'd go 7 kilometers. He's only going for half of that, and we all know that answer is 3.5 kilometers. Okay? So we're going to come back, and we're going to label that. I'm going to take this out. 7 kilometers per hour is now out, and I'm going to write his actual distance, which is 3.5 kilometers gone in half an hour. Now, what about the whip? The whippet goes 25 kilometers per hour and goes for half an hour as well. So we have to change the speed to an actual distance by multiplying it to the time. And if we do that, we all know that this is 12.5 kilometers. Basically speaking, this dog is gone. 12.5. All right. Okay. So let's figure out how we can get the other side we need. Let's label. If we're going to call this W, let's use black here for the whippet. Okay, we got maybe a B here for the bulldog. Then this is the front door. We'll call this D for the door, right? And so the distance we're looking for, perfect, lowercase d. Okay, this can be lowercase b, and this could be lowercase w. But if you think about what we're working with, we actually have a situation where we have a side, an angle, and a side. In that order, that means the angle is in between the two sides, meaning cosine law. So on the bottom here, I'm going to work out the cosine law for this situation. We're looking for a side right here. So I'll just show you the formula first. D squared is equal to the two sides, which are b squared plus w squared. Subtract 2 times b and w, all multiplied to cosine of angle D. And I'm going to pause it, substitute and solve, and there we go. Okay. Did you also get that after substituting, we have an answer of 10 kilometers? Okay, looks like this dog went, 10 kilometers traveled. All right, so here's a cosine law example. You just got to make sure you convert that speed back over, and you are good. 10 kilometers. I had to adjust the screen for a second. Let's talk some more. All right, the Raptors are playing a game, and you and your family are gathered together to watch the game. You are standing 15 steps away from the screen when your big cousin takes a spot in front of you and blocks your view. You turn 35 degrees to the right and walk 6 steps in that direction to get a clear view. How many steps away are you from the TV? Okay, so let's start with the labeling, and we should look something like, maybe use a nice red for this. Let's go with RAP for the Raptors. Well, you started right here. And you had a decent look at the TV, right? And you were watching the game. So you're standing 15 steps away from the screen. So yeah, notice the units that we're using here are steps. It's a little bit unconventional, but it's 15 steps. And your big cousin, of course, comes into the way and just blocks you right out here. And you can't see, okay? So what do? You got to move. And you are going to move to the new spot, which is 35 degrees to the right, and you walk 6 steps in that direction. Okay, so we're going to use an A here, and you're going to end up walking 6 steps here, and we know that you turned 35 degrees. I mean, to the right, doesn't matter though. 35 degrees is the angle there. Okay, the question is, how far away are you from the TV? Well, if this is a P for Raptors, right, then really what we're looking at is we have a side, we have an angle, and we have a side. Side, angle, side. This is another cosine law situation. And the cosine law situations are good in the fact that even though you don't have a matching pair of angles and sides, you can actually figure out some things too. You can figure out this side, right? I'm just going to label out the rest here. We've got a lowercase p here, we've got a lowercase a, but we are going to figure out that r That's our goal. Okay, so we're going to use the sine law, sub it in, and see what happens. So r squared is equal to a squared plus p squared subtract 2ap cos r. I'm going to pause it so I can sub and solve. All right, and bam, you are 10.7 steps away. Therefore, you are now 10.7 steps away. All right, we got one more question, and we're going to look at that in the next part of the video.